All right, welcome everybody to Voltage Drop Series Circuit Lab 1. You would have a lab sheet similar to this one or this one exactly, depending on when you're watching this. This particular lab is going to cover voltage drop and resistance measurements in a series circuit. We're going to start out by having you build this particular circuit right here. You'll notice that we got a power source, a fuse, a normally open switch, and then two marker bulbs and a ground. Okay. Training board looks like this. It's a blank white slate. In the upper left you got your positive terminal, and then in the upper right you have your negative terminal right here. When you lift the lid, hopefully the last person before you put everything back in a somewhat neat and organized way. You should have a 3-wire brake lamp, a 2-wire tail lamp, 2 marker bulbs, a single throw relay, a fuse block, a push button switch, and a single pole toggle switch. You may or may not have a fault box. I got 6 trainers and 4 fault boxes at the moment. And then you're going to have a small pile of banana jumper wires. Some will be short, some will be long, some will be old, some will be new. If anything looks out of sorts or defective or broken, please let me know. We'll take care of it. But I'm going to go ahead and grab the wires out, set those off to the side. I'm going to grab the 2 marker bulbs that we need. I'm going to grab a fuse block and a toggle switch so that we can construct our circuit. Close the lid. I'm going to start with the fuse block near the power source. The legs plug right into the holes. And then if we consult our diagram, after the fuse blocks is the switch, then a marker bulb, and the other marker bulb. Okay. Then we need to hook everything up with wires. Okay, we'll want to make sure the toggle switch is in the off position. We're going to go from positive to one of the fuses. There's 2 fuses that are usable in the fuse block. There's the top one and then the bottom one. So these top pair go to the top fuse, and these bottom pair of banana jacks go to the bottom one. And then it's a series circuit, so I want to go from the other side of the fuse to the one side of the switch, from the other side of the switch to the front side of the marker bulb 1. From the marker bulb, we're going to go straight into the next marker bulb. And then we're going to go from marker bulb to ground. Okay? Creating our series circuit that goes power source, fuse block, switch, marker bulb 1, marker bulb 2, ground. Notice that it's a series because there's only one path for electricity to flow, just like how we've hooked it up with the wires. Okay? At this point, you would be ready for an instructor checkpoint to approve your build. So usually I'll come over, I'll take a look at things, I'll flip the switch on, see that the marker bulbs turn on and then turn off. And it's time for you to start taking your measurements. The meter that we're going to be typically using is these OTC 100 meters. They're a really great meter designed for automotive use. So I'm going to go ahead, and our first measurement is going to be unpowered resistance of the load devices in our circuit. Okay? And so that's going to be our light bulbs. So a little note, when we're making unpowered resistance test, it needs to be unplugged and unpowered from the circuit. And we're going to be looking at cold resistance of bulb 1 and bulb 2. Notice that it says cold resistance, because the resistance changes as the bulbs heat up. So I'm going to set my meter to ohms, and I need to make sure that I have my black lead in COM and my red lead in the volts ohms port. Set that right there so you guys can see that. So in order to take these resistance measurements, I need to go ahead and disconnect the bulb from the circuit. That not only makes sure that there's no power, but that also isolates it so we're not getting any backfeeding. I can rest those in there. They're touching metal, and if you take a look, we're reading approximately, oops, as I move things around, 5.8 ohms. Okay. Do the same thing to bulb 2. And this one is 5.5 ohms. Now 5.2. Okay. So those are our resistance measurements of our light bulbs when they're cold. Go ahead and reconnect the circuit as it was. I'm going to switch this to volts because we're going to do volts measurements from here. And at this point, we're going to go ahead and measure our open circuit voltage. Okay. Our open circuit voltage is basically our source voltage with an open circuit connected to it, okay, with no current flowing in the circuit. So I'll put my red lead on the positive and my black lead on the negative, and you can see the power supply is running at 13.32 volts. If I bring this in real close for a close shot, you can see up here in the upper right hand corner how it says volts. Whenever we're taking measurements, it's very important that we're looking up here to see our units, because this may change to lowercase m, capital V for millivolts, or back when we were doing resistance, we might see a K or an M, which might indicate kilo ohms or mega ohms. So we always want to make sure that we're checking that there. It may be hard to see it on camera, but in person, be sure that you're looking at that there. So now that we've done our open circuit voltage, let's go ahead and start taking some voltage available measurements. In order to do that, we need to have our circuit on and working for accurate, reliable voltage measurements. And what we're looking to see is how much voltage is available to bulb number 1. Okay? So we're starting out with a potential difference of 13.31 volts. And as the electricity travels through the circuit, when it encounters a resistance, some of that voltage is going to be dropped or lost as it pushes the current through that resistance. The only time we really want resistance in our circuit is at our load devices, which in this case is light bulbs. Fuses, switches, wires should have hardly any, if none, hardly none or any negligible resistance to them. So after the fuse, after the switch, I want to know how many volts has gotten to this side of the marker bulb, the front side, and you can see we've got 13.28 volts available to bulb 1. Because this is a series circuit and voltage drops at each of our loads, hopefully we remember from the theory that this is going to be a lot lower because of bulb 1. You'll notice that voltage available to bulb 2 is 6.70 volts. Okay? Because we've already dropped a fair amount of voltage on bulb 1. So this is what's made it all the way to bulb 2 and what's available to bulb 2. So that's voltage available. Notice that my black lead of my meter stayed in the ground terminal this entire time. Okay, that's voltage available. Next, let's go ahead and make voltage drop measurements of each bulb. To do a voltage drop measurement, a direct voltage drop measurement, because my meter tells me the difference between the red probe and the black probe, my voltage drop is going to be the amount of voltage that's dropped in between these two probes, the potential difference. So in this case, the voltage drop of bulb 1 is 6.58 volts. Okay? Voltage drop of bulb 2, I'm going to take both leads. I'm going to put one on each lead of the bulb. and my voltage drop of bulb 2 is 6.68 volts. Hopefully that makes sense. If you remember, this bulb had a little bit more resistance than this bulb, and so therefore there should be a little bit more of a voltage drop on this bulb than this one. Okay, but they were still pretty close, so we still have some pretty even voltage drop measurements. Okay, so now let's take a look at the voltage drop of the switch. The switch shouldn't have any voltage drop. It should not be consuming any electricity. It's merely allowing us to control whether the circuit is open or closed. 0 would be ideal, but usually they never really quite measure totally 0. We always do get a little bit. In this case, it looks like we have about 8.69 millivolts of voltage drop across the switch. 9 millivolts is 0.009 volts, which is hardly any and fairly negligible. Okay? And that's the way it should be for a particular switch. Last measurement we're going to do is the total voltage drop of our circuit, which is the amount of voltage being consumed by our circuit in a working state. And it should be very close, if not our source voltage, which it is here, which is 13.31 volts. Okay. There's going to be some follow-up questions about the voltage drops and resistances, and explaining the sum of the voltage drops for you to do. I look forward to reading those responses from you someday. If you have any questions, come find me. Thanks for watching.